Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is finding the equation of a circle when 3 points given. So far we completed 5 methods to find the equation of a circle when 3 points are given. Now we will start with 6th method. Here is where we will be using the important well-known theorem, angles in same segment concept. Let's see an example step by step. I'm taking the same example with same points. Okay, in this method we will be using the concept angles in same segment. So obviously it shows that we will be using some angle formula. Here I'm going to use tan formula. Let us start with the slope. We have two chords PQ and PR. Step 1 is to find the slope of the chords PQ and PR. Let us just plug in these values in the slope formula. -4, -5 and -3 minus of -6. So plus 6. 6 minus 3 is 3. So -9 over 3, positive 3 would be -3 because negative over positive will give you negative. So before starting with all these problems, you can go through the rules of sign for multiplication, addition, subtraction and division. I have made a video on that topic too. You can refer the video for detailed information about the rules of sign. Okay, same way let us find the slope of PR. We are just going to use the same formula but the values will be different. Instead Q I'm going to take for R. Let this slope be M1 and this slope be M2. Just to avoid confusion, I'm just assuming some numbers for the two of the slopes. 1 minus 5 and 2 plus 6 in the denominator. So -4 over 8, which is nothing but -1 over 2. Hope you're clear with step 1. We are just finding the slopes for the two chords PQ and PR. Now we may investigate the case for which the absolute value is added. So here I'm going to take the tan formula. Let me write the formula and then use the slopes. Now you will understand why I found the slopes M1 and M2. Let us start with tan alpha. We will also find tan beta. Just plug in the two slopes that we got in step 1 in this formula. So we will get M1 is -3 and M2 is -1/2. Half plus 3. -1/2 plus 3 is -1/2. The sign in between would be plus. So -1/2 plus 3 will become -1 plus 6 over 2, which is nothing but 5 over 2. Same way in the denominator 1 plus 3 over 2 would become 2 times. So 2 plus 3 is 5 over 2. Therefore tan alpha is nothing but 1. Hope you are clear with step number 2. We are just finding the angle where angle alpha is nothing but an angle in QPR. Let S be any point on the circle. We do not include the absolute value in the formula. Now let us find the slope of SQ and slope of SR. So let's apply the slope formula for the point x, y and -3, -4. Let this slope be M3. I'm just going to divide both top row, I mean the numerator and the denominator, by a negative sign. Therefore the slope M3 is y plus 4 over x plus 3. The order of the M is important. I'm going to find the slope for SR where R is 2, 1. Let this slope be M4. Let us plug in 2, 1 and x, y in slope formula to find M4. Same as slope M3, I'm going to change the signs by dividing both numerator and denominator by 3. So I'm getting y minus 1 over x minus 2. We are just finding the slopes and applying the tan formula, but just excluding the modulus in the formula. That means I'm not considering the absolute value. Now let me apply the same angle formula. Let beta be angle QSR. For the diagram you can refer a previous video, the same figure, exact same figure. So let beta be the angle QSR. So tan beta formula would be, let us just plug in the values for M3 and M4 we just got in step 3. So we will get replace m3 and m4 by y plus 4 over x plus 3 and y minus 1 over x minus 2. I'm not going to simplify this further. Let this be equation number 2 and the tan alpha be equation number 1. Hope you know a very popular theorem, angles in the same segment. So angles in the same segment would be equal, am I right? Since alpha is equal to beta, you can also equate tan alpha equal to tan beta. Do you agree with me? So just equate equation number 1 and 2. So we will get, you can cross multiply. I would like to tell you one thing. I didn't include the modulus sign in the formula. I repeatedly said you that I am not considering the absolute value, because in case if we considered the absolute value previously, we have to add plus or minus sign in equation number 1 and 2. Okay, so equating 1 and 2 we got this, and by cross multiplication we got the last step. So we will get, we can use one more concept here, opposite angles of a cyclic quadrilateral or supplementary. So alpha plus beta equal to 180 degrees, and obviously tan alpha would become negative tan beta. So that is why I didn't include the modulus sign in the tan formula. Okay, let us concentrate on this step. So by cross multiplication we got this. We need to simplify it further. Multiply the equation throughout by x minus 2 and x plus 3 so that I can get rid of the denominators. So we will get, now you can apply FOIL. Okay, now let us simplify both these sides and bring all the terms to one side of the equation. That's it for this method. We got the equation of circle. You can compare our previous video and check that we got the same answer for the same example. So in this problem we are just involving two concepts. One is slope and the other one is tan formula for the angle. So using the concept angles in the same segment are equal, you're just equating alpha equal to beta. So you get tan alpha equal to tan beta. After simplification we get this equation. If you are not comfortable getting rid of the denominator step, you can just multiply the x minus 2 x plus 3 with every term, and you can simplify it further. Hope you are clear with this method. Let us move on to method number 7, the last method in finding the equation of a circle. We are going to use determinant method here. Let me take an example. Let me use the formula here. Here is the determinant form. Here we are going to use x1 y1, x2 y2 and x3 y3. Let me plug in the values of p, q, r here and let's see what happens. The equation is of second degree and it is a conic one, and you can equate the coefficients of x square. So coefficients of x square equal to y square, and there will be no xy term, so it is a circle. We are just plugging in -6, +5, -3, -4, 2, 1. Okay, by simplification we will get, I'm going to use Laplace explanation here. Laplace explanation is keeping this and multiplying this cofactor. Same way, keeping this and excluding this one and multiplying this factor. You will understand once I write the step on the board. You can follow the way I have highlighted. Now I'm going to keep this as, and also notice that the signs will be alternately changed, positive, negative, positive, negative. So the second term would be negative, and this is the coefficient, and multiply excluding this row and column. Now keep y as a coefficient and exclude the row and column, multiply this as a cofactor. Now exclude the top row and the last column, so it would become, so 1 should be multiplied with this cofactor. So we will get, see, I'm continuously changing the sign, positive, negative, positive, negative. Although the determinant is simple and compact, the evaluation is a little bit complicated. You should know how to break down a higher order determinant. I'll explain you and make a video about the multiplication of determinant in a separate video. Now by simplification, the first term would be 60 and second is 360 and this one would be 120, and this would be 900. So we will get, by simplification, we will get the equation of circle. That's it for this example. Okay, I'd like to explain that step clearly now. I'd like to explain how to expand this determinant. Same as the Laplace expansion, keep this as a coefficient, and here also we are going to change the signs alternately, and already this is a negative sign, so plus times negative is negative, so this would become, now you have to exclude this row and column, so cross multiply. Negative 4 times 1 is negative 4, minus of 1 times 1 is 1. Now consider this one, keep a negative sign here, excluding this row and column, you have to do the cofactor multiplication. Negative 3 times 1 is negative 3, minus of 2 times 1 is 2. So we will get, same way, exclude this row and column and cross multiply with a negative sign in between. Negative 3 times 1 is negative 3, and 2 times negative 4 is negative 8. Already there is a negative sign, so negative, negative, positive. Now let's simplify it. So if you add and simplify, you'll get 60. So this is how we got 60 here. Same way you apply the same concept for the other determinants too. I'm getting 360. Let's see how to work out this breakdown. If you simplify this, I'm getting negative 120. Now let's work out the last determinant. So this would become 900. So this is the formula to find the equation of circle. Just plug in the points x1, y1, x2, y2 and x3, y3. So we will get this step by simplification. Expanding the exponents and applying the signs, we will get this. Now we are going to apply the Laplace expansion. Keep this and this cofactor and apply the negative sign, exclude this row and column and apply the cofactor. Same way we got this step. Now let me explain how to break down this. So by this one I'm getting 60, and next one is negative 360 and negative 120 and 900. Plugging in these values, so we get, simplifying the equation, we get the equation of circle. That's it for the determinant method. In case if you have any query, you can let me know. Hope you are clear with the session. We were discussing method 6 and 7 in this session. So that's it for the equation of a circle when 3 points are given. You can apply whatever method that you are comfortable until the direction asks you to follow one particular method. Once you understand these concepts, you can apply all the concepts in other problems too. Hope you are clear with the session. See you in the next